right? We discussed about the path difference and phase difference. So till this point, we talked about that phase difference and path difference of a particle on a single wave. But now we are talking about the path difference and phase difference between two waves, especially the phase difference between two waves. Okay, for this concept, when we are having to, or when we are going to find out the phase difference between two waves, we will consider that, for example, there are two waves. Let me draw the waves. Suppose this is one wave, wave number one. Okay, this wave has some time period, definitely 20 milliseconds. It is mentioned here. If you see, this is 20 milliseconds. This is a wave which has started at time t is equals to 0, and after 20 milliseconds, its one pulse is completed. Then in 40 milliseconds, its two pulses are completed. At the same time, there is another wave which is starting from time t is equal to 0, but the time at which it starts, any time when we started observing that wave, the wave was having its highest, yani the particle was having its maximum displacement. But for the first wave, the particle was at minimum displacement, yani at equilibrium position. So this wave is now in this way. Did you see? It has the same time period, 20 milliseconds, because its peak is started. Its peak, yani crust and crust, they are having same time period. So as I told you, that those waves which have same frequency and same wavelength, they are called monochromatic waves. So I will just consider these waves in a situation that if I have these two waves, then I will find their phase. These waves are definitely out of phase. Nah? It seems that they are out of phase, isn't it?
Yes.
Okay, so when they are out of phase, so how much out of phase they are, we can calculate this. The basic basic concept behind the phase difference is same as this one. That phase difference is basically uh, small t divided by capital T into 360 degree, or small t divided by capital T into 2 pi radian. But the game is they have the same time period, and the time period of the wave is 20 millisecond. I told you that how much time period does it have? 20 millisecond. But the problem is small t. Small t is that time. Small t is the time. वापस देखे जाना. Small t is the time with between identical positions of two waves. देखो, very important again. Identical position of two waves means your black wave. I will say that the black wave is started right from here. I think this all is just in this way. So I can erase this and write it again. ये देखो. अब problem क्या है? Problem is कि my black wave is started from 0, and it is its one pulse is ended after 20 milliseconds. Meanwhile, the red wave was not started from here. It was started from anywhere else, but its first peak is completed here, right? Did you check? The first wave completed over here. It means the wave was started from where I have drawn in the diagram this way. The wave was started, yani it has completed its 3 quarters before it reaches to this wave. So इसका मतलब ये हुआ कि once I will start this, I have one point over here and I have second point over here. So I can take the distance time difference between these two identical positions. This is one situation. Second situation is you can take the time period, sorry, you can take the time difference between two consecutive peaks. Both are same issues, yani you will not penalized, you will not be penalized. Same has, yani both have same uh, logic, but answers would be different. It does not matter कि answer same होंगे, but answers would be different. So if I say that there is 15 millisecond time difference, then I will get that okay, the waves are 270-degree out of phase, right? But if I take time is equals to 5 milliseconds, then I will get 90-degree out of phase. So either 90 or 270, both waves are basically, if I say that 90-degree, so what can I say? I can say that the wave one, let's say this is your wave A and this is your wave B. Wave A is lagging by wave B by 90 degrees centigrades. Sorry, 90 degrees. But if I say the 270, so it means that wave A is leading wave B by 90-degree. That's it. Nothing difference. So the path difference, the phase difference is 90-degree. That's it. So if you write 270 or 90, answer would be same. Okay? So here I have selected all the points which are in phase. They have zero phase difference. All these points which are at this wave, they have zero phase difference. So just check it out. This point is of this point has 2 pi phase difference. This point has 4 pi. This point has 6 pi. This point has 8 pi. So when the waves are at a phase difference of 2 pi, 4 pi, 6 pi, 8 pi, and 2 and pi, so we consider that all these points, yeah, all these waves are actually in phase waves. So this question is also asked to you in different situations to sketch the wave for its intensity, for its amplitude. You know, the previous topic, that previous topic is linked till this point. Got it? Yeah, is it clear? Do you people hear me?
Yes.
जी सर क्लियर है।
Okay. अब आते हैं, there is another very important topic, and just give me 2 seconds. I will restart that.